ARK. Hi, Sophia. You missed last week, I think. Am I not hearing anyone? Hello?
Hey, how's it going?
Oh, just making sure.
Yeah, I got you.
On this laptop. Normally don't work on this laptop. Let's see. No. It's kind of big there. Did you finish the ethics chapter?
Yeah, I did. I mean, I think the video kind of summed it all up pretty nicely. What'd you think?
Yeah.
I actually had a pretty hectic work schedule this week, so I was glad to have it coincide with kind of an easy week lesson for the course.
Yeah.
We're right in the middle of a championship hunt, so my time is not my own for a lot of this stuff.
Man, I just 7 more minutes and this guy is pinging me from work. It's like, I can't see the server. What's the server name? Fuck on it.
Yeah, that sounds about right.
I hope they don't put that in the video. I hope they edit that. Where's my other 2 presenters? There, huh? Just gonna have to run it myself, I guess. Did you happen to see next week's lesson in like the book form? The book goes from 194 to 263, but you skip chapter 7 and you go to chapter 8, which is kind of odd. Anyway, I put that in the agenda. So where's this other guy? What's his name? You won't see him. Okay, Henrique. Let me send a message. Okay, there goes my stuff then. Okay, let's see. Good evening, Enrique. Welcome to the study group.
Thank you very much. Are we starting soon? Do I have time to shower? 5 minutes?
Quick one.
I'll be back in 3.
I guess we could wait. Welcome, Snow. I don't recognize the name. We'll be starting in a few minutes. Hey, Daniel. Thanks for the video.
Hello, how's it going?
Okay. Can you guys hear me okay? Should I turn it up a little bit?
I can hear you well.
Okay. I was taking a look at some of those videos I put on YouTube, and sometimes the audio isn't as clear as it could be. What is up with the waiting room? All of a sudden I have to admit everybody. Before it was just automatic, and now you guys are going into the waiting room. There goes Butch.
Yeah, I was wondering about that too.
Yeah, I don't know
Yeah.
what they changed. And
Yeah,
I
I've been using it at work for like maybe 3 years, but like ever since the pandemic, like they have like a new feature and it like, you know, we're like, what, how do we disable this? It's like every week.
So we're just waiting for a little bit. We had a new guest. He's been active on the Slack channel, Enrique, and just came on. And I don't know who Snow is, but I know Sophia because she was there last time and she posted on the Slack last week. So welcome back, Sophia. But maybe we can ask Snow to chat or introduce him or herself. I don't have, let me go get that. think I just erased my stuff I had done. And Google even warned me.
All right, I'm back. I'm back. I'm ready. Sorry about that.
No problem. We're just waiting. Let me see if there's anyone else. No one else is in the waiting room. Where is it Isaac? And what's the other guy's name? He's active on the Slack channel. I forget.
Yeah, I tried to do the here, but I think here doesn't, it's disabled for,
When he's doing
obvious reasons.
that, what's his name? Dave, the one's
Dave,
running
yeah.
GCP stuff. And where's Anya? She's a presenter. It's just going to be you and me, Cliff, I guess. How long do you think yours is? 15 minutes, 20 minutes?
Yeah, something less than it.
Okay, let's just start rolling here. Can I share screen? All right, everybody. Okay. Welcome, everyone. It's Fast.ai, October 6th, our 5th meeting. How about that? Rolling right along. It's the ethics chapter, and I call it a break because it was kind of given to us as a break. So welcome, and welcome Henrique Curry. Hopefully I got the name right. Hopefully you typed it in the chat right. And I think Snow is on there. I didn't do it for everybody that was coming in, but hopefully everyone starts to know everybody by their name. Just do it on the Slack channel, I'm assuming that you'll get to know each other. Again, try to turn on your video so everyone can see when you're talking. And it's good because it'll go up on YouTube eventually, and then at least you can, oh, there's Anya. At least then you can say to your boss, to your other people, see, I'm in a study group, right? And we're participating, learning, deep learning, blah, blah, blah. And of course, put your name. It's hard when you have Snow and we don't know who Snow is. So if you could put your name, or at least chat your name so we can refer rather than a pseudonym. Oh, now we got everybody coming in. I should have waited 5 minutes. Again, share your knowledge. We're going to have that. Hopefully Anya is ready to share her piece. And then I'm not sure if we'll have Cliff go second. I actually put myself second, but I can go last. I think that it might take some time, and maybe you guys have more questions and you want to walk through that. And here is our past speakers. Thank you very much. Hopefully this goes on a screen in YouTube, and then you can just point to your boss and say, see, I'm even speaking, right? And I'm doing my work, and I'm learning, and give me a raise. And now we're going to have, are you ready, Anya? Hello?
You're muted.
Hello, can you hear me now?
Yes. So are you ready to present?
I think so. Let me figure out how Zoom works. I'm not a Zoomer, but I will be.
I will make you a co-host, and then you can.
I can just click share screen, right?
Yes.
All right. So while I'm doing this, I just want to say it's probably nothing new for some of you who took Andrew Ng's course, but from the last week, we had some discussions and some people asked about that. So I thought maybe sharing it would help other people. So that's the inspiration for me, what I'm trying to do. All right, so let me share my screen. And how much time do I have? Like 10 minutes?
It's up to you. It's pretty open, I think.
All right. Okay. Do I share? Okay, screen, so it will show everything, right?
Yes.
Okay. So I want to, okay. So first of all, a quick, very quick, what am I doing and why I decided to speak up. So I started with the name Jeremy's Roller Coaster because I liked his example where he used a super simple end-to-end explanation of how gradient descent works. But then I realized that this course for me is a roller coaster because I'm having fun. I feel like I'm learning. I like it a lot. And I do experience bumps here and there. And, you know, it's all the attributes of a roller coaster. I'm going all over the bumps and I feel definitely challenged. And my main challenge is that every chapter has a main topic, but then it has a bunch of tangents. We go, you know, into these different discussions and they're all valuable, but it's hard for me to stay on track. So this was Jeremy's example. This is how he showed us the 20 data points of the roller coaster, how you determine speed. He gave us a function, he gave us a loss, which is MSE, and then he gave us an example how in 7 steps and 10 iterations, we got this value of MSE, which doesn't really give me anything. I mean, 632, is it good, is it bad? I don't really know. And then I'm looking at these parameters. Also, you know, nice to see them, but what does it mean? And then last week, Andy, you came up with a question. I think it's a very good question. What's the difference between loss and cost? Because if you go on this link by Daniel, you know, it looks like people are looking up because the language between different courses, between academia and practitioners is very different. And then, of course, I love this comment that, you know, a loss function is a part of a cost function, which is really an objective function. So this is this is why I wanted to share how Andrew Ng does his formulation of a problem, how to approach any supervised machine learning problem. So this is part of his original course. This is a very old course, not the newest one. I haven't taken the newest one, but this was probably 2014 or something like that. And this is how, you know, this is a background. This is a supervised learning problem. And more formally, that means that our goal is that we have a data set and we want to learn this function H. H stands for hypotheses. And this function H has input X and output Y. So in his case, it's just one input and one output. So living area and prediction price of the house. So we want to find this function H of X, which is a good predictor of Y. And Jeremy's example was super similar. So now I'll go into the notebook. So Jeremy's example was super similar. So I have this notebook I can share with you guys if you're interested. Let me remove this. So, okay. So if this is too much because we're all overwhelmed, I wrote this short description, and the idea is that jargon and notations are very different, but as long as we understand what we're doing, then all of it is the same. And I like how Andrew splits the machine learning problem into 4 parts. He chooses to show us model representation, parameters, cost function, and objective function. And once you understand that, it helps you to keep track of what you're doing, why, and how. So let me show you his representation. So this is his example of a function with one input, one output. In machine learning and academia, this is called univariate linear regression. But all it means that there is one input and the function is a line. So he organizes it in two parts: hypothesis, parameters, cost function, and goal, which is objective function. So this looks very mathy. Don't worry about it. I'm gonna translate it into Jeremy's terms because, you know, he doesn't use the same language. So I took Jeremy's roller coaster model, and it's pretty much the same, except that notice that he doesn't have linear regression, he has quadratic regression, which is polynomial. So instead of having 2 parameters, he has 3 parameters. So all of it is absolutely the same. I'm just adding one more parameter for this polynomial power of 2. So it all looks good. And now I'm translated into Jeremy's language. So what academia calls hypotheses, we call it a model, right? So Jeremy's model for roller coaster was A, you know, this is parameter A, parameter B, and parameter C, and we have one input, time, and this time to 2nd degree and with no polynomial. So we have our model, we have our parameters, which consist of weights and bias, one bias. So linear problems usually have 1 or more weights and 1 bias. Then we have a cost function, which Jeremy calls a loss function. So loss function really, in Andrew's course, there is a concept of a loss function, and it usually means just the difference between prediction and actual. And this prediction minus actual is part of the cost function. So loss in Jeremy's term is also here. So there is loss per data point. So if we have 20 data points, then we have 20 different losses. And it's a difference between predictions and a target. And then when we average this, which is a mean, so he keeps calling it a loss function. So in his case, for roller coaster, we chose the loss function to be MSE, which is mean squared error. So this is the error, then we square it, and then we find the mean. And the objective function is to minimize this MSE. So if we find the best parameters of A, B, and C to find the minimal cost function or loss function, depends on how you grew up. I grew up with the cost function language. So this is the whole point of splitting everything you're working on into these 4 areas. And what it practically means, you find that best line that fits your data. So with Jeremy's example, this was the data, and he called it, he said it's end-to-end SGD. Well, this is gradient descent because we're not doing batches yet, so it's not stochastic gradient descent yet. So this is where we want to find the line, the best fitting line. So I wanted to see how to find that best line. And to find that best line, I wanted to know the answer. So I wanted to kind of cheat. I wanted to know the answer first and then reverse engineer finding those parameters. So what I did, I got rid of this randomization thing. I pretty much removed it, and I just I calculated my parameters by hand. So parameter A is 0.75, B is negative 1425, and this is our C. So later on, when he walks us through these examples, so he showed us 10, we took the loop 10 times and we found this value 632, and these are our parameters. And as you can see, these parameters don't fit the model at all because, you know, our last points look like this. So what I wanted to do, I wanted to see if I can fit the model. So what I did, I pretty much did the same stuff, but I played with the learning rate, and I played with the number of loops. So by changing the learning rate and by looping instead of 10 times, but 60,000 times, I came up with these parameters. And my parameters so far are much better. This is the data, and this is how it fits. And then I decided to see if it can do anything better. So I increased number of loops to this many, and thankfully on GPU, it happens super fast. It only took me like 11 seconds. And you can see it fits it better. So I just wanted to share with the group that, like, for me, every time I read a chapter, I have to understand those 4 parts. And then when we go on tangents about, you know, log likelihoods and all the important side steps, it kind of, I understand, okay, this is important, but I just want to keep track of what I'm doing, where I am, and how I'm doing it. So I did the same for the model 3 versus 7. So I didn't translate it to Andrew's terms because that would look super mathy. I did it in Jeremy's terms. And it's very similar, but with classification, we have this sigmoid function. That's the difference. Then instead of ABC, we have number of weights. This is our model. We multiply our input by parameters. Our parameters are weights and bias. As you know, with pixels, we have 784 pixels. So we have 785 parameters to fit. We're not just fitting 3 numbers, we're fitting 785 numbers. Our cost function is a little different, but it's pretty much about that difference between actual and prediction. We're just doing some manipulation because classification, binary classification, is about comparing everything to numbers between 0 and 1. And objective function is the same. You minimize the loss. As long as you define your loss, you know how you define it. It's not MSE this time, not RMSE, it's this thing. So once you minimize it, we can find the best line that fits this 785 parameters. So I think I'm done. Well, I want to just say that out of all the roller coasters, this is my favorite. I like this course. Any questions? Sorry I took you through all of this so fast. And I don't know how many of you didn't know this, but hopefully 10 minutes didn't.
Hey, on the loss function that you have on the bottom there,
Uh-huh.
that's the one that he was giving it, and that's the under that subtitle MNIST loss function.
Yeah.
That's where you got that.
Yeah.
So he basically calculates something that is comparing the mean, and that's the loss.
Yeah. So at the,
like
correct. So at the end,
next one. Go ahead.
At the end, he averages it, right? But first, he takes a prediction, which is the sigmoid. Remember, by sigmoid, we convert everything. We basically normalize the data, so the value is between 0 and 1. So if it matches your prediction, you know, if prediction is 1 and your real value is 1, then the error is 0. If prediction is 0 and the real value is 0, then the error is 0. But if you predicted wrong, then the error has a value, and it depends on the threshold of that value. So this is his formulation. I didn't give you Andrew's because his looks, it's amazing, but it's really hard to read. It's all in Greek letters. Like, I'm used to Greek letters by now, and I find this challenging, but you know, it depends where you started. So yeah, that's what I wanted to share. And I think it just lets me be organized And if I didn't study data science in depth, I would want somebody to share this with me. So that's what I'm doing.
I think it's great.
Yeah.
I definitely come from a little bit different background, and you had mentioned that you're not used to the objective function, and that's exactly what I'm used to. So
Oh,
it's funny.
yeah. I am used to objective function. It just, I'm sorry. I've never heard the term so far in Jeremy's course.
Oh,
Like,
yeah.
like he just says, we want to find the best parameters, which is true. But I never heard them say our objective function is this. Sorry.
When would an objective function not be minimized? Is there ever a maximize?
I think because, so in gradient descent, we are optimizing, we're finding that lowest point, which is a convex function, right? Do you guys know what a convex function is?
Sure.
It's pretty much quadratic. It's just like this thing.
It has a minimum, a local minimum.
Yeah, it's this local minimum. So as long as the data fits linear space, so we're trying to find this lowest point, even if it gets like down here, because computing, as you saw how many loops I had to do like almost 200,000 loops to find a better model. So I got somewhere here, and that was close enough to approximate. So with the I'm trying to remember what you asked. So when would this not be to minimize, right? So with gradient descent, because it's a convex function, we're finding this point of the lowest slope. So as long as the slope is 0 or very close to 0, then it's great. I also noticed when I was playing with learning rates, I started diverging, right? So I was getting lower and lower, and then up. I went up and up and up, which you need to stop. When you notice you start going up, it's like your algorithm is no longer optimal. Anything else?
So you decided to take the noise out of his original roller coaster was trying to model maybe some randomness, like the roller coaster, the friction in the roller coaster wheels, or something.
So I can, if I had all the time in the world, that would be my next step to actually fit this. I decided to take the noise out because I wanted to find the answers. With randomness, I was distracted from the real answer. I wanted to find this formula. Exact formula.
Okay.
So because I knew once I had the exact formula, then I know my answer. So my answers are these three numbers. And when he gives us his answers, these numbers are so far from what we're looking for. I like, where are they? Like, these are these 3 numbers, and they're just so far. And I wanted to see, like, what does it take to get closer to those numbers? So I had to change learning rate, and I had to loop, almost 200,000 times. I stopped because I decided, like, I learned in data science not to be perfectionist. So I stopped at pretty, close enough. So this was my less number of loops, and then more loops, and this looks good enough. I'm done. So if now I don't need to know the parameters for sure. Now I don't need to see how close. Now my parameters look like this. They're much closer to what they are in a perfect function. So now I know how everything works, so I can introduce that noise and be comfortable with it. So that's the gradual approach to figuring out where I am and who I am.
No, I agree with that. That's one of my standard practices at work, is to use denoising filters to try to get rid of sensor dropouts and things that are, unpredictable. And just while you're trying to understand the actual problem, And then once you think you have the problem solved, then you let all that noise back in and solve it again and see if you actually found something that does find the actual problem. That's a very common procedure for what I'm doing right now.
Yeah, I think for me, it's always breaking it into smaller parts. And once, then I can move on. And time is an issue, so I have to fight my battles like all of you. So, but I decided to spend time on this because at some point I wasn't sure if his loss function is the cost function, and now I am sure. All right, maybe it's time for somebody else.
Thank you, Anya, for that share.
All right, I am stopping. I'll give you the notebook if you guys are interested. There's nothing fancy here. There's, no Fast.ai, no super in algorithm. It's just simplicity.
Right, and now we're gonna jump to Cliff. I'm going to make him co-host. And if you can share your screen. And you're on mute.
Okay. Let me share my screen. Okay. Okay, so I want to give a quick presentation about Docker and Docker more for data science. I think the primary thing that people use Docker for is like a big company like Netflix or large web companies will use it to scale up and down their services. So Docker is a form of virtualization, but I'm not really going to cover anything kind of related to like what a big company would use it for. I think it's really great to use for running Jupyter notebooks or running different Python environments. What I found is that like if I'm running some library, it'll be only compatible with like Python 3.6, and on my computer I have Python 3.7. Or I started with PyCharm, so I don't have Anaconda on my machine. And you can also then, like if you start up a Jupyter notebook server, you can just close it off your computer, and it's just within the container. So Docker, I'm sure some of you guys have used VMware, but Docker is just a much lighter virtualization than VMware, and I would say the primary difference is that when you use VMware, you want to keep your virtualized device for a long time, whereas with Docker, the containers get destroyed very quickly. So you don't want to store any data within the container. So you want to put it within an outside database, or you bind it locally to a volume. So you can install it on Mac, Linux, or Windows 64-bit. Most computers can run it. You might need to enable Hyper-V and just enable it in your BIOS, but it should work. And just a disclaimer that with Fast.ai or anything that you have to train on a GPU, it won't work on the Mac because Mac needs NVIDIA, and they don't support NVIDIA graphics cards. And it's only supported in the most beta, the fast-string beta on Windows, but it should be available there. So if you want to train with it, it probably has to run on Linux, which is a big downside. Anyways, moving along, the big thing to understand with Docker is the images versus the runtime. So the image of the like notebook or whatever server you're running is within a Docker file or within Docker Hub or in a registry. But when you go to run it, you configure it either with the executable Docker machine, Docker Compose, or Kubernetes. You won't use these. This is more for like bigger companies, but you run it locally with Docker executable or Docker Compose. So basically it inherits from the previous. They build in layers. So mostly it'll build from like an image released from like Ubuntu or Alpine, but they also build on top of other ones that people created. And so I just want to show you guys, with Jupyter Notebooks, they released official images. So you can run SciPy or R or TensorFlow or Apache Spark. And so it describes them all here. But once you install it, if you just choose, this is Jupyter all Spark Notebook. Let me just show you it spinning up. A simple command, you can spin up this, and then it's building all the layers on top of each other, downloads them all, it'll run it. So I just wanted you to see the layers. But pretty much every major software, if you Google it, like Python, you can run 3.8, 3.9, 3.7. Fast.ai has, like, they have a notebook dev. They just have these images, and they'll have instructions on how to run them. TensorFlow has official ones, so you can just spin up like a completely running build on your computer pretty quickly. This will only take a few minutes, and then just hit run. And so just to go over. Thanks.
Slow down.
Yeah, I know. He's on the wheel. So this is just the sample file. So this one just copies like whatever you've written into an Ubuntu and then runs it in Python. But these are some more complicated ones. So I generally would start with this one, where this is a Docker file, and you can add in like whatever requirements, whatever Python requirements. You just write to requirements text, and it'll install it. And then here's one that I wrote where, I mean, this is super complicated, but you can generally get these off of GitHub if there's something you want specifically. And this just made like a JavaScript Jupyter Notebook server. So instead of Python, it like uninstalled Python, and it installed Node.js, and then D3 and Axios, and I was able to use it in the REPL that way. So you can just kind of quickly spin up and down the Jupyter Notebook servers, which is great. Okay, and just to show you guys the runtime. So this is an example of just using the executable. So this is like the Fast.ai Docker run GPUs. And so there's a lot of like configuration here. Like this is basically binding your local directory to the inside the virtual instance, and this binds the port. So it goes 888.888, but if you change this to like 50, then you could make on your local machine, it would be 50, and it would just map it to the port, so that you can change the port really easily. And you can also like insert your own directory. But because this is so big, and it would be very difficult to type this out, they have another thing, it's called Docker Compose. And this lets you put all this into a YAML. And so you can just put all this data into a YAML. And then these are like the volumes, this is the port mapping. And it's pretty easy to configure through this. This just makes it a Jupyter lab. Instead of like the Jupyter Notebooks, it's a little bit of a different interface. So let me see if this finished. Okay, so while we were doing this
It's running.
chose the AllSpark. Yeah, it's running. So for security, they have this token. So otherwise, if you ran it like at an airport or something, anyone would be able to like type it in. Do it. 1 second.
So you configured and ran an entire server with one command that
Right.
is now serving out Jupyter Notebooks locally on your machine.
Yep.
Yep.
And so, and the thing that's super important though about this is that when you just run it this way with this command, if you put a notebook in here, if you upload or create a new notebook, and this, so it'll run R. I mean, it's pretty well configured, this notebook. The only thing is you've got to push this back to a volume. So you have to map a volume, or else, you know, the containers, they're almost like, they're not actually like purely running in RAM, but if you turn it off and turn it on, you'll like lose your data, right? So
Sure.
the whole design is that you don't want to put anything that's in state in the container. You want to map this back to a folder. So you need to add a volume when you run a Jupyter Notebook server, and make sure that any important data is within that volume.
That's what I
And
do.
so-
I just map a local drive so that I can start the container from my local drive, and it just shows up under my work directory. All my files, all my local files show up under the work directory that you just showed.
Yeah, and
It's just that
so,
simple.
yeah, it's super simple once you get it installed. So here, I'll just demonstrate. This is the Fast.ai container.
I could never understand local Python environments, so this became my Python environment management system.
Yeah, hopefully, I'm trying to copy, but I'm using the Windows keyboards on the Mac, so hopefully that didn't kill it. Yeah, so if you see, like, I added these as volumes, basically. So this is just a local directory on my computer. It just completely replaces the directory, completely binds it and maps it.
Things you save will stay on your local system. They won't go away.
Yeah.
Yeah.
Yes. Yeah. And I just want to show just a couple important commands. Docker PS. These are just how to work with it. So if I go to my terminal, I'll just open a new one. Okay. So this just shows, and so I'm running 2 containers. One is the one I just ran. This is the Fast.ai one, and then I'm running the ONNX Jupyter Notebook server on port 8887. So Docker PS just lists it. Then if you look at the name here, you can, if you type docker exec IT, and then put in the name, flamboyant bows. These are just made up names. Do bash. Now you're into the workspace. So I bash in just to sort of see the folder structure to create a volume. And then how to exit. That worked. Okay. And then you can also just shut down the container by saying docker kill flamboyant bows. And that is it. So just a quick introduction to Docker. I think it's super useful. But again, you need an NVIDIA GPU on like a compatible computer if you want to train on it. So it's not useful for that, but I like to work with it because I've just found that different libraries won't be compatible with different versions, you know. So this allows you to manage your versions and make sure everything works.
You can train on just non-deep learning, right? Deep learning stuff would take the GPU, right?
Mm-hmm.
But scikit-learn, you can run plenty of models that don't require GPU.
Yeah. Does anyone have any questions?
It was nice, Cliff. I appreciate that.
Thank you.
No other
Okay.
questions?
We're ready for you, Andy.
All right. And now, here we go. This is the full MNIST solution, but rather than doing it in Fast.ai, it was in PyTorch. So let me share the screen. Okay. And how do I get this? Okay, before I go on that, I wanted to go back over the Fastbook Chapter 4 questionnaire in what is a ReLU, right? And then it's just, you know, it's a little different than how we see it when we look at like the activation function, because when we first did the ResNet one, when, you know, in chapter 1, that's using a convolutional, I think that's the way you pronounce it, a CNN. But what the MNIST one is, they want the ANN first, and then I imagine they'll move to a CNN later. Anyways, this piece is really important because this is the activation function, right, that you'll be using. And then it's really important to know like what this is and the activation function, because when I'm going to explain, you're going to see these two. And then what the difference between an F ReLU and an NN ReLU. So just F dot something is going to be a function. It's going to be a Python function, but it's coming off of the PyTorch library. And then NN.ReLU, as it says here, is a PyTorch module. So it's actually a class, right? So then you're able to, so basically one's a function and then one's a class. So I just want to go over through that.
We're only we're seeing the overhead, your slide.
Oh,
Not your screen.
that's not good.
It's okay. That's you.
Let me try that again. Screen share. Okay.
Code. Very good.
So this is what I wanted to show, right? So chapter 4, we had some questions. Number 34, what is a ReLU? And then draw a plot. And then it just shows you, you know, you start the negatives, you zero out the negatives, and then you go, this is from -2 to 2. But it just replace any negatives with 0. But that's like the activation function. So again, it's really important that you understand this activation function and what it's doing, right? And then the difference between F ReLU and NN ReLU. So F, again, is a function and NN is like a class, right? And I'm imagining you could use everything as a function, but I don't know why you would. So let me jump to the notebook here. So I'm just going to show you that I've put this in the GitHub, and then I just got this from this guy, right? So he's going to do a little different. He's going to import Torch Vision, and Torch Vision is their sample data set stuff. So you're going to see this, and then it comes with 2. He's pulling 2, right? So you're going to see the transforms and then the compose here. So let me just run these, right? So I just imported that. I've already downloaded the data sets. So of course, you know, it's just going to look back and say, oh, I already have them. And again, it just goes in here, and then this is what you get, right? So that's when you run this, it'll just download, and it's fairly small. I think it's like 150 meg or something like that. It runs pretty quick. And then this is the stuff that the data loader. I remember Daniel was talking that PyTorch has its own data loader and Fast.ai have its own data loader. They're very similar, but yes, both of them have their own data loaders. So this is the PyTorch version. And so this, in this example, I'm just pulling 10, right? And I think you do get, I'll show you in a minute. I'll walk you through the code in a minute and just kind of run this through so you kind of see the whole thing first. So I just basically broke it up in the train set and test set. And this is what I was talking about, this NN linear this is the activation function that is being used. So you can see he's got 4. So he takes that 28 by 28, the 784, and then he's got 64 kind of incoming neurons that it's passing into. And he's passing this into here, running it through this linear, and then coming out of 64. So he's basically got 64 neurons passing all until the output he gets 0 to 9. So that's kind of the piece that, I think it's the same in Daniel's code, but I think he's got like an NN linear and a ReLU, and I think that was coming out of the book. I know I can check, but you can see, and then he's got 3 kind of layers. This one is 4. And then here's the forward. So this is the first like pass through. So you can see that it's using the F dot, which is what I was telling you about. So this is just a function call. So it's just passing this X, right, through these activation functions. And then here's that log max. And then apparently you have to put this dim1. And he does do a little explanation. I wasn't clear on what this dimension is, other than, how you do stuff in pandas. And in pandas, there's like this dimension that you can get either the column or the rows. I think this is doing the same thing here. So again, I'll just run this for you.
Yeah, I think in pandas it's referred to as axis.
Axis equal.
Yeah. I think this is the same thing that it's doing. I'm not clear though, so I would have to review that. But I give you all the notes. So you can see he's got, 794 in, and he's got it out. 64 in, 64 out, and so forth and so on. Okay, so this is what I was getting confused on is like this opt-in, right? And what is this, right? So here's the loss function, and I guess it doesn't have to be loss function, it could be loss or whatever. But again, this is the cross entropy loss, and it's in the next chapter or the next section that we're going to do, right? This is where we kind of stop. So there's a bunch of losses you can use. You don't have to use SGD, but there's a whole bunch of them. And then the optimizer, right? I think there was a question in the Slack, like what's the learning rate and what's the optimizer and what are these, right? So these are different optimizers you can use. He just happened to use Atom, which he says is probably the best, you can use as you're learning, I'm guessing. But if you look in PyTorch, there's a whole mess of optimizers you can use. So I'll just run that. And then this is running on my laptop. So we'll just run this and then talk through it while it's running. And, oh, I didn't put the time. I put the time in the other one. Sorry, guys. I put a little timer thing there. Oh, I did put the time. So he's going to do 3 epochs pass through this, right? And then, he's getting the data. He's zeroing his gradients, and then he's passing in, right? So he does this -1. I think we saw it. I think it might be the same. And then he's doing not the regular loss like SGD, he's using this NLL loss. And I'll show you where the documentation for that is. And then he, of course, does the backward propagation, and then he does the step. And then my poor little laptop is like dying. And then in the end, he'll get, a pretty good rate here. And my laptop is like dying. Okay, so that's the first one. That was pretty long. I guess when you're presenting on Zoom, it takes a little bit more processing power.
Yeah.
But what I liked about this is I didn't have to run it on a GPU just to step through and make sure I understand everything. So, and then we'll go through this, but here's what I did for you guys. So I gave you these, and this is basically all, I put all the comments in here. So you can you guys see that? Mm-hmm. Okay, so here's the link where I got it from. And then here's his basic introduction. So if you understand like what you're doing in deep learning and neural networks, you can kind of blow through this, right? He's basically explaining, the hidden layers. And then, he's talking about the weights. this activation function, we used ReLU, right? And then, it's a nice little, kind of overview and introduction. And then he shows you, import, and then a little bit about the tensors and stuff like this. But the meat, I think, is this one. When he does this data, I thought that this was very interesting. So he does this, and then you can see that, I let it be here, and then it went pretty quick when I was downloading the thing. So if you go to Torch Vision, this is all the data sets that they give you to play with. So in my mind, I can kind of use these, and you can see there's a lot of MNIST ones you can play around with. So that's probably an easier way to kind of get your own sample data set. And then if you want to know like how to do the read transforms and data sets, which is this code right here, right? This right here, this transforms and data set, because they do it here, right? And then they do it to tensor. So if you want to know what that's actually doing, I also gave you the link here. So you can see that, again, it's going to PyTorch tutorials and stuff. But I wasn't understanding until I got to about this down here, this. So when you get to transforms, I just kind of skipped all that, and I just went to transforms, and then I said, oh, I think I'm understanding what they're doing here, right? So you may not understand all the documentation, but it's something to go on. And then, I'm basically following, I'm giving you all his notes. So the first one I gave you in that demo thing. Okay, 187 seconds, not too bad. And let me just run this for the accuracy, and you can see. So he doesn't have all the little graphs and everything, but he does get 96. And he says, you have to remember that, this is only 28 by 28 on a grayscale. Your pictures, one image of your, photo is going to be much harder to do because these are cropped in the center, kind of clean data for you. So you really have to kind of get this down first, I think, and play around with this and make sure you understand all these little things he's doing. And that's what he's kind of walking you through and doing all the stuff for. So he explains this data loader here and, what he's doing, and I saw another video. This might be too small. I've seen it like at 100, 300, 600, 1,000. So you can play with that, right? And he basically kind of explains each piece, right? And then he gets you the data, and he's only doing 10, so he does this for loop, and then he breaks there. So he gets these 10 data sets, and then there's the 10, right? So these are the same thing we saw in Jeremy's, but getting these tensors back. And then he shows you, instead of, I forget if we're using matplotlib, but he shows you here's one of the numbers, right, at 0, 0, and he's getting this. So he shows you like where the data is, right? And it's in all these tensors that you have to kind of go through. And then he does something interesting. He does this data balancing, which I never thought about until he mentioned it. He says, imagine you have a data set of cats and dogs, but you have 72 images of dogs and 1,800 cats. So you're going to have an imbalance, right? So in the one that we did with dogs and cats, we had an even balance, but a lot of times you just get your data and maybe you'll be like RK and you'll have like 10,000 images, but they'll be just the same car going around the same track over and over. It's not like different cars and different tracks with different paint schemes, right? You only have, basically you have like this weighted set, right? That's giving you an imbalance. So he does.
Well, yeah, and I mean, there's only like 6 Toyotas in our series, but there's 19 Chevrolets. So the amount of picture, it's naturally imbalanced.
Yeah. So you just have to have that domain expertise to do that. But a lot of times you're just getting the data set, especially when you're learning, and you don't consider these questions. And then he did a nice thing. He did this like kind of dictionary loop. And then he figures out oh, there's 9.8% of zeros, 11.23% of ones. And he does mention that, if this was 30, well, of course, your activation functions is not going to work out, right? So I don't know if you trim this down or stuff like that. When we did like the bear and stuff classifier, supposing it's not 150 pictures, right? It's probably like tens of thousands of pictures, and you're not going to do every one of them, right? So eventually you're going to have to do this kind of making sure your data set, even before you begin, is make sure that it's kind of balanced in what you know. Right? In the case of RK, he knows that he should have more, but it shouldn't be like 50% of something, right? It should be kind of weighted evenly or, in his domain of expertise, right? So he was showing this.
And honestly, I don't know how it should be weighted because it is such an imbalance of what the vehicles are. So I think that's a whole nother topic of just doing like what he's doing here and, exploring, well, what are these percentages and then what is appropriate? Do you just make it statistically relevant? So each car did so many laps. So each car of a manufacturer, should you have the right percentage of pictures for each event? It's not clear to me yet.
What breaks if it's imbalanced? What doesn't work?
Well, your activation functions, right? If this is like 30 or 40%, your model will be good at predicting ones, but when it sees in the, the test set that it's a 4, it might think it's a 1, right? Or, their weights will be different, right?
I'm not sure about that.
Yeah, so you kind of want an even model like this, especially if you're doing, if it's binary classification, the one that we're doing 3s and 7s, it's okay, right? Well, maybe not. I mean, if it's all 3s, then it's going to be all 3s. But that's what I was talking about, that, in the course, we were just given this binary classification. But in the end, when he tells you to do this whole MNIST thing, it's not a binary thing. You can't say, well, is it a 0 or nothing, right? You have to say, you have to do this weighted thing, right? It's going to be, so many percentage of 0, so many percentage of 1, 2, 3, 4, and then you're going to back propagate and try to find that loss and minimize that loss. Anyways,
I think you're to David's point. I think what happens is when you have so many of one type of thing
in training,
your parameters tend to optimize towards that thing that's in your training set.
That's
so
yeah, I guess. I mean, they showed up in training more often, so it would make sense maybe that
plus the loss, right? The loss that you're doing, the cost function, is loss function, or I forget the other one.
And I think it's almost like if you think of it as like the out of domain problem.
Well, they're all but they're labeled properly, right? I mean, so you're not seeing as many of one class as the other.
Right, but you want your model to generalize, right? So that when it sees a 7, it predicts a 7, right? But if there's too many ones or too many of another number that is weighted.
I'll grant you, if it only had 1 7 and 10,000 of the other ones, it probably wouldn't do very well on another 7 because it didn't see enough variation of 7s.
Yeah.
But I don't know that's guaranteed just because you don't have a big population. Maybe there's only one kind of 7 in the whole world.
But I mean, if you think about pictures of cars, say you're trying to guess what the number of the car is.
Now that's different.
And it's getting, your image is skewed. That number is getting skewed because it's on a door, and it's on a roof, and it's on a bumper. And so if you only have a few of those options for one thing, that's where I think I'm seeing some of my issues is that it's not that I'm being presented this beautiful MNIST centered data set that like, here's this, like, even though it's handwritten and it's probably not as ugly as my handwriting, but it's kind of ugly. It's not this 3-dimensional skewed thing that's being presented.
Well, yeah, you're saying that the images in your test data, not even your validation data, doesn't fall into the domain of what you trained on. It is out of domain.
Yeah.
Yeah. That's that's definitely a problem.
Yeah, and
because you're not guaranteed the cars are pointed the same. I mean,
Right.
by definition, the cars aren't pointed the same direction.
Yep.
Like the camera's not mounted to the car. The camera's some dude standing in the stands.
So
right,
it's fairly,
shooting a car coming around the corner.
It's fairly likely. It's fairly likely you never saw many of the angles, ever.
Correct.
Yep. That's an interesting problem. That's a very interesting problem, actually.
It's I like to call it ugly. It's a very ugly problem.
Yeah. So for those of you who don't know what we're talking about, I think we had this in the very first 1 or 2 videos. I'd encourage you to go back and look at our case, like little sample thing he did and little demo. And it was about, these pictures of race cars, and he's trying to figure out the number. And
I just
put a little demo of that.
I just watched the NASCAR race.
It would be nice to see like everything he's learning now, and then version 2. So that's something on your horizon. I'm going to put that on your plate, RK. So you got to come back.
And then if you watch the race from this weekend, there were cars upside down. So they're flying through the air, upside down, completely out of domain.
Okay, so this is the part where you're building the neural network now. And this is why I said this piece is important, because this is where he starts to go and this is where I was having a little hard time with the NN, and it looks the same, but one is like a functional piece. So he's just using the functions out of here is what he's doing. So that's why it's NN, and then he's going to call the linear off of this. So you'll see that. So he basically does the same thing. He makes like this first sample class of that he's going to put in a model, and then he kind of fills it, right? So he says, here's the class, here's what he's doing, right? So he's just kind of showing you like little pieces, just like Jeremy was doing. So when he builds the model, it looks like this, right? So he's got all these NNs, all the linears. So the linear just means everything's connected to everything else. So these, 784 is going to be connected to these 64 neurons. So you can imagine, they got one neuron and it's going 64 connections. And then you got the second neuron all the way down to 784. And then the same thing here. So that's what linear means. It just means like this linear kind of web between the 2 layers. And this is all your hidden layers, right? This piece here is your what they call hidden layers. And then finally, you're going to have this out layer. Right? So he does this, and then that's how he gets that. This, I think, print net, when you put it in a net thing, I think this is part of PyTorch. And then, he explains here, your images and stuff like that. And then he does the forward piece. So this is your call that you're going to push your data through. So then, he's just showing you this, but then he modifies it in the next one doing this, right? So you can see, he just kind of copied right here, but he's going to change this one. And he changes this one to this softmax, which you will have in the next lecture. Sorry for those, kind of jumping ahead, but he's going to do this log softmax. And then he does, I think he might do this dim one. In the video, he does explain what this is, but he too just says, just be safe, just, if you need this, just put dim equals 1, your dimension equal 1. So I still have to kind of go through that. And then he then shows you, he's going to like come with this output, and then the output here is going to be this tensor of 10 possible classes. So the first one, he does this random, right? And then he pushes it into his model. So it's just random numbers, right? So of course he gets this, right? But this is kind of what you want to see, right? Because eventually you want to see it with 10 numbers, and you're going to see it hopefully 0 to 1, right? And you take the percentage, and then the closest one to the 1 would be the prediction. So that's how you get to this one. And then this kind of gives you the whole thing here. He just explained all that. So he's going to walk through this part, right? The opt-in, which is the optimizer, and the loss function. So again, if you want to know, what the loss functions are, you can just go to this. And these are all the loss functions you can use. And there's the one he's using, right? But there's a whole mess of loss functions you can use. So that was my question, right? Is that the, cost function? And, so I thank Anya for kind of going over that. And then the same thing, what is this optimizer, right? He's using Atom. And if you go into this optimizer thing, here are all the optimizers you can use, right? So there's the SGD one that comes from Fast.ai, but you can use Atom and all these other ones. So I would, it plays to, play around with some of these just to see, what they do and, kind of learn as you go along. And then, he's showing you like the one hot encoding stuff, right? So he's showing you like what the hot vector for 3 would be, which is 0, 1, 2, 3. So you would kind of look for that. And that's why he's using this cross entropy. So he's basically explaining why he uses this, right? So I guess you don't have to create your own MNIST loss function. You just plug one in that they already have.
Sure.
But it's good that you know what that is, right? Like Anya was explaining in what is that, and kind of explain at least to yourself, how Jeremy got to that. Right? So then he explains the optimizer here. Oh, I messed something up. I put it in Markdown. Anyways, he explains the optimizer there, and then he's doing the sizing of the steps. I don't know if he has a picture of the sizing of the steps. Anyways, he shows a picture of like oh, maybe I have it here. Can I go here maybe? Let's see.
Roll.
Oh, so this is what the problem with that learning rate thing. So what if you had a quadratic function that looked like this, right? So here's your learning rate and it's too high, and then you're just stuck between this and this, right? And you just keep bouncing back and forth. Or you do it too low and then but then you get stuck in here.
And Anya mentioned seeing some of this behavior in her project too.
Yes, I did.
Yeah, so actually, let me see.
So you want to find that optimal learning rate.
Yeah. So,
which has its own techniques too.
Yeah, so he has, maybe I put the wrong thing. Anyways, if you go to his website, you'll find all the rate pieces there. So he is taking a learning rate like 0.001. And he says, usually it's fine, right? But again, you have to kind of play around with. I did find something that there's this learning rate that will adjust. So I didn't get a chance to look at all that. And then he does, again, putting all the stuff together. And then what I like is he's telling you each of the code here, what he's doing, right? So he's commenting every piece of how this is being trained, right? So now you can see, oh, this is what's happening here, and he's doing this. It's similar to the Fast.ai, though. I mean, if you understand Fast.ai, this is very similar to what they're doing. The only thing is, in Fast.ai, they were doing that binary classification. So you didn't get this kind of bigger picture all in one shot. So he then goes down here and then does the correct, but then he says down here, he says this number is very high. And he says, don't expect this number like this. You're probably in the real world, you're not gonna get this. He says, it's very rare when you get this 90. He says, otherwise something's wrong with your model. He says, normally you wouldn't get this high of an accuracy. And the only reason you're getting this high is because you're 28 by 28, you have it cropped in the center. I mean, you have these perfect images to play with. But again, that's just so you can learn and you can figure it out, right? You can do, your understanding of what's happening, right? And then he does, how he picks one out of the feature set, and then he just shows you how to, break it down so you can see. And then he does the argmax, and then he gets the actual kind of biggest index, which is the prediction. So he kind of shows you like, okay, here's how you would, if it's still confusing, you're not understanding this piece, then he's kind of showing you this. And then here's where I got the link from. But here's Jeremy's on PyTorch. So I don't know, I linked it in the thing, but I forgot to mention it. But this is by Jeremy Howard, and you can see he's using the MNIST, so you can kind of cheat, if you will, and start to walk through his, right? And he does the same kind of thing that you would see. So it's like a cross, between here's PyTorch and here's a little bit of Fast.ai, and he does, kind of do the same steps that you just saw from this video here.
Well, I guess maybe I'm missing something here, but it seems to me that the thing that you ran through was a ANN, not a CNN.
It's an ANN, yes.
Yeah. Because everything's fully connected.
Yes.
All the layers are fully connected.
Yes.
So my understanding of the benefit of going to a CNN is that you're filtering down levels before you get to fully connected levels.
Yeah,
So
and unfortunately, you don't get to CNN until chapter 13. And I was just like, oh, I did all this work. Okay, now I'm ready to do a CNN, and then we don't get that, And again, like Anya said, it goes through these little tangents. So maybe we'll get some more, like, I think it's classification or something, segmentation. I forget what it is, but I wish after this we can do the CNN right after this, because I'm kind of like.
The thing is, I just like to add that it wasn't covered in the first 8 lectures. We basically stopped just before that. But the thing is, everything's in the book. So if you have the book, you can definitely study it on your own. And in my study group, what we did was we took chapters after the course, which is actually good, because just going through the CNN chapter, which is just right at the end, it's chapter, I think, 13.
Yeah.
So if you want to cover that, we'll probably, if you want, beyond like tackling the 8 lectures, if the study group wants to go on and tackle that, I think it's a nice exercise if you want to go into CNNs. But I think the whole point of covering ANNs, or artificial neural networks, is it's kind of the same. Once you get into like the more what do you call this? The ANN is the simplest one that you start with, but you don't remain there. You go on to other types of architectures, and so I think it's a good exercise to really learn the basic one first. So I think that's the important thing. One tip I have is that when you're looking at the architectures, like that snip of code that Andy was showing, where there were like steps, the forward method. The thing that would really help is when you're trying to understand it, think about the shape of the inputs and the activations as it's going through that. So you might want to just stop there and say, okay, what's my input? So my input is shaped 3 by, let's say, 784. So, or maybe it's not, no, in this case, we have one channel, so you might have a batch size of 64 by 784, and then I do a matrix multiply on a 28 by 28 with, and so it's 784 rows by 64 columns, and my input is, let's say, 64, let's say a batch size of 64 with 784. So it's like the crucial thing there is always understand the shape of your tensors as it's going through and when it's coming out at the end, because even stuff like the ReLU, they don't change the shape of the input to the output. So it's always nice to like be aware of what the shape is and what, for example, the f.logmax does. What's the shape outside? What's the output of this? Given a particular input of, let's say, X, always think about that as you're trying to understand what the module is doing, your model is doing, so that, because most of the time the problem is really, you get these errors where they don't learn, and it's probably because you didn't like initialize it properly, or the shape of the model isn't correct, and it has to do with like the shape of your inputs. And it's always the case, whatever architecture we're going into, once we go into beyond just the computer vision stuff, that you always think about what the shape of your inputs and outputs are. So that's my tip.
Yeah, and do you know, Butch, do these have to be like base 8? Or can you just pick whatever? Like
No. The thing is, what Jeremy would always say is experiment, play around with it, because that's how you learn, is you play around with this stuff. So in this case, he built something like 4 layers, I guess.
Yeah.
So 4 layers of, starts out with 64, 64, and 10. And so in some other books, or they call it the hidden layers. So these are 4 layers of 64, 64, and 10. So these are your hidden layers. And so a lot of what people did in the past was they played around with it. Was, okay, let's try this and try that and try, and then but the thing is, it's like the only way you'll understand this is if you play around with it. And then the other thing is, this is just the starting point. Remember, there's a lot more other types of layers as well, and that will be covered in the later modules. So yeah, so just be aware that this is just a starting point, and then the best way to learn is to play around. Don't forget to like run the code, because you might get focused on just trying to learn the theoreticals, but if you don't run the code, you won't learn as much. So always play around with the code, try stuff out, and that's the best way to learn.
Yeah,
I think I would add that in choosing things, the way this network feeds through, though, is it's the output of the first FC1, the fully connected one, is 64. So the input to fully connected 2 has to be 64. Right. And then 64, the ending part of FC2 can change to a different size, but then that has to feed into the FC3 input. So they're going like end into the beginning, end into the beginning. So you can change that. And then at the very end, FC4 has to be 10 because there's 10 digits.
Yeah, my question was, what if I did, like 121? And I know it has to be 121. It's kind of like this odd number, because everything I've seen is like base 8.
No,
so
I can't hear you if you're talking about
and see, that's the best way, is just run it afterwards.
Yeah, I didn't get a chance. So I was wondering, if you didn't take that 128 or 256, if you just did like some weird crazy number, you did like
you can put any number. It's just developers, coders like numbers that are in our world, which is base 2.
Yeah.
People put 42 all the time because that's the
Hitchhiker's Guide.
Exactly. So it's you can put 121 there. The question is it gonna produce a better model?
Yeah.
Right.
Yeah.
And that's called the architecture search, and it's an active area of research right now. And like there's tons of people researching how to create this layering. What's the best way to find those numbers?
Yeah.
I'm having trouble with the 64 becoming 121. What's the mapping between 64 to 121?
Actually, the thing there is that you think of, the way I would think about it, my mental image is I always think of matrices. So my input is 28 by 28, so it's 784, right?
Got that. There's that number of pixels.
So that's the number of pixels. So if you think one image is just one long string of 784, and my matrix, the weight, the first weight for FC1 is 784 by 64. At least that's the original. So, right? So you have 784, I guess.
You're right. You're right. Yeah,
Inputs,
they have to,
X1, right?
They have
784.
Right.
Connects to 64 of these.
Right.
Right? The hidden layer 1 is 64 pieces of them. Your hidden layer 2,
sure.
If we follow Andy's example of 121, these 64 layers are fully connected to the 121. So each of these circles, the neurons, are connected to the 121 next layer, to the next layer, the hidden layer 2. And then so on to the next one, which you can say, well, I want them to be, what, 10 or whatever. So these are the neurons that are fully interconnected. So if you think about it, each of the neurons in hidden layer 2 will have 121 connections. So the shape of the, so if you think of the number of neurons as the columns in the matrix, so you have 121 by 64, that's the weights, the square of one. So the number of parameters for hidden layer 2 is multiply the columns times the number of rows, which is 64, right?
Okay, I think I missed that.
So hidden layer 1, you start out with 784 rows, which matches the inputs, right? Your inputs will be 784 pixels, right? And each one of them goes to the 784 input, your hidden layer 1. But there's 64 of them, right? So you're like
64 outputs.
Yeah.
Correct.
So the real useful thing is, I can try and explain to you, I guess, if you want me to like just.
No, I've learned it before, and I just can't visualize it in my mind.
Here in this picture here, right? You have the inputs here.
So
3. You have this hidden layer 2, and then the output. So just think if you're picking 0, 1, and 2, or 1, 2, 3, right?
Yeah.
These are 4 going in, but each of these is this one is going to 4, this one is going to 4, this one is going to 4, and then it drops to 3, right? So it can go like to 10, and this one will go to 10, this one will go to 10, so forth and so on.
Doesn't X1 have an input dimension of 4, right?
Well, X1 is your input.
Right, and it has what the number of pixels
into each layer. So X1 is like a number.
A column. X1 is a column.
No. Well, X1 is
Pixel value.
Is it like an RGB value?
It's a pixel with 3 values for
X.
So you have a 28 by 28 image, and you like stretch it out into one long row.
So X is X1 just one of the pixels?
Yes.
1 pixel.
Yeah.
Thank you. Okay.
Which probably be mostly zeros, right?
Yeah.
Comes
Exactly.
in and maps. But when you get to that hand drawn, when it's a little gray or black, it'll be more toward a 1.
Yeah.
So you'll get like point.
Okay, I got it. I got it.
So
Thank
the
you.
weights are the connections,
Yeah, right here.
right?
Yes,
So each
there's
one of them is a weight.
AX plus B. It's the A.
Yeah,
Yep.
exactly. And the
And
B
is a bias.
is associated with each cell, with each neuron, the bias. There's only one. So there's a number associated with that.
Across for all of them. Yeah.
Yeah.
Okay.
So I'm a little confused on why is X1 just a singular pixel?
Yeah, if you like think of the image as normally it's a grid, right? 28 by 28. But that's why there's this view minus one. View minus one changes the shape of that 28 by 28 grid into one long
What you saw there.
vector.
What you saw there was a 3-pixel image.
Yeah.
An
Correct.
image, one input with 3 pixels,
Yep.
and that baby goes through the network.
Yeah, that's
all the
actually
way through the network.
3 blue 1 brown is actually a good
Oh,
visualization.
I love that guy.
Yeah. That one, like, if you're still confused as to just go and view that.
Where is it?
He explains Bitcoin better than anybody I've ever seen.
Yeah.
Yeah, so if you still have questions on that, why is it one thing? This is the one where I must have watched this like 1,000 times before I finally got it. But it's somewhere here where he tells you how it's flattening out or something.
Yeah. There you
right
go.
here.
Yep.
So now you-
Yeah. That example.
So and that's only one. That's just one sample.
784.
That's one sample.
Yeah.
Yep. It's exactly why they're using 784, because they're also using MNIST.
Right.
Do you have more questions, Cliff?
Good. I'm definitely gonna check out this YouTube channel.
Yeah.
Oh
that's
yeah,
great.
I must have watched this like, forever until I finally figured it out. Like, oh, now I know what I'm doing. So in here,
I also watched that one a couple times this week.
Yeah, here he uses cost function, just kind of one, which is why I was getting confused when it was being said as loss function. I was like, what are they talking about? So thank you, Anya, for that great demo.
Oh, it's like in life, it's good to be multilingual, right? You speak different languages, but you mean the same thing. So cost or...
It's just when you start learning it and then you see one way of explaining and you're like, wait, I thought I understood this.
Yep.
And then you don't see anywhere in Fast.ai they talk about a cost function.
Yep.
Or the objective function. So I will put that in the chat. Do we have any more questions? So I'll put it up on the GitHub there.
Was this, it says Harrison Kinsley. Was there a video? I guess I missed that.
Yeah.
Where does this come from?
He does have a video on that. Let me see. Well, it's hard to find his name. And actually he has, so this is all what he's doing. He does have one that he's working on, I guess, which is, now of course I can find it, right? He's doing TensorFlow there. Oh, here. And I just gave you the first 4, which is here. His 5, 6, 7, and 8 does the CNN. So if you're interested and you want to know, if you wanted to jump ahead to chapter 13, you can watch those. So this is the video he walks you through, but here's all the code. that he's doing. I just put all this into your Jupyter notebook, so it's easier for you to kind of reference. But yeah, he's got I think it doesn't show, in one of the ads, if you go to the site, I think he has a book or something that he's trying to sell. And it's basically building a Python using, deep learning, pure Python, no libraries, no nothing. I thought, well, that's kind of interesting.
Ouch.
Yeah.
Could you add this link to the chat?
Yeah.
Yeah.
That I will do. So do we have any more questions? Let me see. Where's my Cliff? So do we want to do the Jeremy Howard, or pretty much everyone's full to the brain like I am? I'm glad to have the ethics one.
Yeah, it was a nice break.
Yeah. Because Butch, can you give us a precursor? Is it going to be hard for lesson video 6? Which 6, 7, and 8? Which is hard?
Yeah, I think. I think there's also stuff like you were talking about in 6. We basically extend it to something like what happens if your pictures has several labels associated with it. So we start out with MNIST with like chapter 5 is what we call more than 2 categories, right? So 6 is just extending it to what if your images have more than 1 label. So it extends it there. And again, it also covers like the loss function again. There's also stuff like the practical stuff, like you were talking earlier about what the learning rate is, how to pick the learning rates. And so we also cover a tool called the Learning Rate Finder, which is actually something that only Fast.ai has. So you probably won't find it discussed anywhere else. But it discusses how to, there's a tool that can give you a graph that will try to predict what the best learning rate is for a particular data set. And then there's also some discussion on, I think one point that you raised earlier was actually a precursor of that, which is that the learning rates doesn't have to be the same, right? I mean, sometimes you want a small learning rate, sometimes you want a bigger learning rate. Because if you, and there's something in Fast.ai called discriminative learning rates, which we already talked about, where we apply different learning rates to the different layers. But we also think about during the training, in order to train as quickly as possible, you might want to start out with a small learning rate, increase it as you're learning, and then kind of at the end, start slowing down again. It's called, it's a technique called annealing. And we also apply that by default in Fast.ai. So you get to learn all these practical stuff. It's not always like we go deep into the theoreticals of all these techniques. It's just that these are the things that we find useful. So if you're doing something practical, like what RK is doing, he's really trying to use it in his work. These are the things that are useful. It improves the training very quickly. Whereas if you use something like standard PyTorch, you'll have to implement all of these things on your own. So I guess in terms of my advice is just keep on doing stuff, running the code, playing around with different data sets. And at the end, at least for the next lecture, there's a little bit of practical stuff. There's a lot of practical stuff, actually. Not a lot of theoretical stuff, because The theoretical stuff is basically chapters 4 and 5, I think. But the rest of it is more of the practical stuff. I think when we get to the 7, when we get to tabular, that's when we go back and study more of like the theoreticals, where we talk about new types of architectures. Yeah. So that's just a preview.
Butch, how do you know all this? You already read all the book?
Actually,
you went to the course.
I did attend the live course.
Oh, I see. Because I'm barely keeping up with, with the
No. I took the live course, and I also added. I attended the study group, okay, where I learned a lot because we covered the entire book. We just finished last week.
Wow.
Up to the we went back and took. There's this chapter called TTA and Progressive Sizing, chapter 7, which we missed because it's not covered in the lectures. But it's a good chapter if you're like if you want to like reach high accuracies and so on. So we went. That's the last chapter that we took. And actually, our discussion coming up this week is what do we do next, which is actually a good place to be in because we covered all the chapters. But it's a
do you know?
Yeah.
Will they have a live class for the second half? Like, are they going to release that soon, or is that in progress?
Nobody's like, whenever we, everybody's been pestering Jeremy about it, I guess. So his answer is always, "I'll get to it when I'll get to it." It's like he never, he doesn't promise any schedule. Basically, he's saying yes, we will, but as to when, he always like squeeze. I guess he doesn't want to answer that because he doesn't know himself.
Yeah, but it's not currently running.
Oh, the best thing I guess is, yeah. So the best thing I think is what we did was we decided to go on. I mean, there's already all the materials that needs to be learned in the books, in the notebooks and in the book. So you can learn it on your own, definitely. So doing it in a study group is actually ideal. So what I noticed was because we stopped before the CNN, when we covered it, yeah, it's actually pretty good. We understood a lot of the concepts of CNNs, and especially if you do the questionnaires, you do learn a lot. And then I think even better is there's this further readings, and if you do that, I think even without the lectures that Jeremy is doing for part 2, we pretty much covered a lot of the topics. And what you realize in the end is the whole book is about how to write Fast.ai from scratch and understanding what you're doing. So if you see how Fast.ai is built from scratch, and this is like even going beyond that areas where Andy was talking about. You're not using Fast.ai, you're using PyTorch, but it goes even deeper than that, where what if you didn't have PyTorch? What is it that you're doing?
Mm-hmm.
So it's kind of, it doesn't like focus on that, but it does go through that level where it talks about, I guess, how do you get the gradients and like the chain rule and stuff. So we do cover some of the math behind it in the end, but the way he does it is you kind of want to just say, I know how to do this in terms of practical stuff. I can apply it in my work, and if I want to go deeper, it's because I need to, because I'm using it in something that I need to, and that's when I need to go down deeper. But otherwise, most of the time, it's like, focus on the practical stuff. There's a lot of things that you can learn just doing it, running the code, building your own data sets, trying to get high accuracies. Just as I love what RK is doing, because it's like, this is real stuff. He's like trying to get to something useful. And Fast.ai is very good at that because there's a lot of defaults that will try to help you to do that. And you don't have to understand everything at once. I think if you go back to the first lecture where he discusses his approach in saying, look, there's a lot of things that you need to learn. But if you just focus on the big picture and try to do something useful. And then when you don't understand anything, that's when you try to go deeper. So it's hard. It's kind of hard, I guess, to try to leave, trying to understand everything at the start, but rather focus on, I'm trying to build something right away. Don't wait until the end. Try to apply it as quickly as possible. And then when you get stuck, and that's when you need to say, oh, I need to understand this better. I need to go down deeper this hole. But at least you know that you're doing it because you're trying to apply it to something.
Right. I've said this before, and Anya will agree. When you take Andrew Ng's course, you spend many weeks just doing all the partial derivatives. You build those by hand.
Yes.
And I just sat for weeks trying to get the matrices to match.
Yes.
And this is much different. This is like, here, I'll give you a tool for that. It'll even tell you when the things aren't right. So it's a much different approach. They both have value, and there are, of course, the opportunities to dig into this material in further chapters. It's almost the reverse. You do the theory later, not
exactly
at first, and that's very powerful.
That's why he's calling it a top-down approach. And
I see.
His idea is his metaphor is like learning how to play baseball, I guess, where he's just start out by playing baseball. It might be not the best, but you might not be the best. It's when you start.
You're definitely not going to be good at it.
Right.
But you'll learn how to play the game.
Yeah, exactly. And you'll have
a 2-year-old how to play Connect 4, and he whipped my ass the other day.
Yep.
Yeah. So if you enjoy playing baseball, that's when you start getting into like, okay, really learning it and practicing it and getting fit into it. But the motivation should still be that the fact that you enjoy doing it and that you get something out of it rather than just focus on try to focus on the fundamentals first.
Hey, Butch, I have a question about the live course. Is that the paid for through the university course that you're
actually? Normally before the pandemic, I think in 2019, the paid course was a live course where you attended classes in San Francisco. But what happened was they canceled the live class this year due to the pandemic. So it was all online. So I think there were still some who signed up for the paid course for USF, but that was just more to get the certificate. Like if you want a certificate, and you paid something like $2,000 for
it was
the
like $2,000.
course. So basically I'm here in the Philippines, so I just took the online course. He invited basically around 800 students to join the course, and probably around 200 finished. So
maybe you can get us on the list for the second half of this course.
What?
Maybe
I don't know.
You can get the group on the list for the second half of the course.
No, the thing that qualified me was just my participation in the forums. He found that he invited all the people who are active in the forums. So I guess if you go help out or ask questions or just be active, helping other people out, answering questions, it gets you qualified.
Yeah.
So that was his criteria the last time.
That's how the deep learning stuff, deeplearning.ai, Andrew Ng's variation on Coursera works. If you start answering stuff in the forums, you are asked to be a moderator.
Yeah.
Yeah.
That kind of thing.
Yeah, that's great.
And I think it fosters community. So I found that answering questions really helps me out as well, because that's when I try to understand, do I really understand what is the topic or not? And that's my motivation for attending this as well is, first, how to handle study groups, which is, I'm pretty impressed with how Andy is doing it, to tell you the truth. Of all the study groups that I've attended, the way he balances out participation in the whole class, I guess something like probably the Toastmaster background, is really a big advantage here. So yeah, and that's one of the reasons why I'm attending, is I'm learning how to handle study groups, but also answering questions also reinforces my learning. So yeah, that's all I wanted to add.
Thank you, Butch. We always look forward to your participation because you went through it once, so we can kind of avoid those speed traps when we're going too fast and not understanding what we're doing. We're just shift, enter, shift, enter, shift, enter.
Yep.
I find that if you go back through the questionnaire, and even if you know them and you just go back through them, just glance at them and just make sure you're understanding, you know, like I told you that I had to really slow down when I got to the, you know, the NN and the F and everything, and make sure I really understood that, because that was the thing that was tripping me up. And then I keep seeing it in Daniel's thing, and I said, I still don't understand what this thing is doing, right? And then, you know, through the questionnaire, it kind of reminds you, okay, make sure you know this, make sure you know that. So highly encourage you to take a look at that Fastbook questionnaire, the answers. Everyone know how to get to that, right?
Oh yeah.
Yeah. So just look at that. That gives you a nice, good summary. Make sure you understand before you move to the next chapter, and, you know, kind of validate yourself. I mean, if you're stressed for time, like most of us are, and you just need to get through the chapter, I'd make sure you kind of review those questions and make sure you get them down. Because it was really good review for me before I like moved on to the next section and heard another video and another video. So try to balance out your time with video too. Don't spend it all on YouTube. There's thousands of videos like this, so just be careful. Looks like everyone wants to just continue the study group going through the course, the book.
I do too.
So I guess we'll find out when we get to lesson 8, right? If we're still alive by then.
Yeah, I don't know if we're kind of wrapping up, but I have.
Go ahead.
Anybody has used the Numba package? It's a package that allows you to compile your Python functions into the C layer, the Python layer, and improve performance for like looping and things like that. I've just started looking at it because I have a project where I'm processing 1 million rows of data, and I'm doing all these different processes on it. I was just curious if anybody had any experience with that.
Nope.
I've heard of Numba, yeah, but yeah, I mean, I guess this is kind of outside the main kind of like the areas where you get into the practical stuff that you need for your particular domain. Like, yeah, because there's only, GPUs can only help so much, especially in terms of, yeah, when you have data in memory already and you're manipulating. But I guess when you're trying to move the data from disk to memory, you still need something to speed it up. And actually Python isn't the best language for that, which is why Numba might help, so that you still stay within Python, but it kind of will try to speed it up. This is one of the reasons why Jeremy would like to move away from Python, actually. He's studying
big on Swift now.
No, there's another one, because the Swift effort kind of stagnated because the guy who's leading it kind of left. Chris Latner, who was like one of the instructors in the 2019 course on Swift, kind of left Google and moved to another company. But now one of the areas where I think Jeremy is probably very much interested in is something called Julia, which is another language, but I guess it's also compiled. So And they're thinking of building something like Fast.ai, a Julia version of Fast.ai, but taking all the same concepts that they're using.
But the issue that I take with Julia is, well, what do I do for my Excel interface? Right? Because like, just as an example, like the thing about Python is there's so many open source packages that I can just use for all these domain specific things that I need.
Yeah.
And all the new things that are coming out, like Julia is great and it's fast, it compiles fast. I mean, it runs at near C speed and everything's great about it, except for when I need to interface with Excel, I have to write all that myself. And that's a nightmare.
And the thing is, isn't it interoperable in the same way that Swift was, like would work with existing packages? So as long as, like, I think, doesn't it translate to LLVM to Python code as well? So it should.
I'm not sure. I'm not sure. That's something to look into.
Because
I know
one
that.
of the advantages of Swift was there's this layer. I don't know if we want to go into this in this forum.
Yeah, maybe offline. Does anyone else have some question? Henrique, are you okay? Was that too much information for you?
Yeah, I'm gonna have to try to do the MNIST data set myself. And then if I have any questions, I'll put it on the Slack.
Yeah, and we have some others, Sophia, and I see Yuri on. You're okay as well? No questions? No, I guess not. So we're wrapping up here. Don't forget, it's going to be lesson 6, right? A little bit challenging, of course, as Butch mentions. I think it is quite challenging on lesson 6. I just took a little snapshot just to get the book information, but book information is on your agenda. It's on the left side. That's what Daniel was asking for. But again,
is it notebook 5 or we have to finish notebook 5 still?
Yeah,
right?
it's like part of notebook 5.
Okay.
And yeah, I didn't figure out what Jupyter Notebook it was, but I figured out the pages. So just look on the agenda. Maybe next week I'll put the notebook as well.
Well, you know that spreadsheet that you gave, or you made a reference to somebody who had mapped out what lessons and everything were on the which notebooks apply to which of the video lessons. That is perfect. That is exactly on, by the way.
Okay.
I mapped it out.
Is that you that made that?
Yeah, I did. Yeah.
Oh, great. It's perfect.
I was trying to follow along and I couldn't figure out like where to read. So, yeah.
Yeah, I can.
Curtis is asking for that. So maybe you can post it back in the chat or something.
I forget where you put it. It was somewhere. I just made a copy of it.
I just found it. I'll copy it down to the bottom of the Slack.
Yeah. Anybody else?
Just one thing. It isn't related to anything we're discussing today, but I published a short 2-part article on Medium. It's basically not, my audience isn't you guys, because you already did, I think, lesson 1 to 3, right? Or at least where we did the binder thing. I wrote up something like an article that will step you through everything, to creating your data set, to building your model, to, I guess, running it on binder, all on Colab, so you don't need to install anything.
Oh, cool. I want to try that.
It's in the Slack channel, or I can post it here, I guess. I'm just looking for, what do you call this? For
reviewers.
Yeah, because if you step through it and you run into a problem, just tell me about it. Like, because it's a hands-on article, so you basically run Jupyter notebooks. So just looking for feedback.
Yeah, I read a lot of Medium articles. They're pretty good. There's a whole Python or a whole data science specialization, which it's usually pretty good.
Yeah. Yeah, it's a follow-up to something, an article that was published 2015. So it's been a while since I wrote something for Medium, on Medium.
Thanks, Butch. Anyone else? Boy, we have a lot of chat this time.
So I had a question for next. I'm still trying to catch up to you guys. So for next week, where are we going to be?
Lesson 6 on the video, and that covers in the book page 194 to 263, but you have to skip chapter 7. That's
Okay, I see it. Yeah, I see that list in the chat. That helps. Thanks.
yeah.
Yeah.
Anyone else? Hopefully you're not getting lost. If you're getting lost, you're falling behind, post in the Slack during the week. Try to reserve some time. Somebody's going to answer you. Cliff and Daniel seem to be on there all the time, as well as Dave. So, and I'm on there too. I know RK posts here and there. We all get busy, but we all can help each other. All right, if that's all, everyone, thank you. We shall see you next week, 5:30, bright and early. Have a good one.
Thank you very much.
Guys.
Thanks.
Thank you.
Take care. Have a good week.
You too.